Hello everyone, welcome to my YouTube channel Patashala. I am Shilpa Pradeep. As you all know, we are going with the first chapter of class 9 mathematics, the number system. In the previous videos, we have learned about the major key concepts we have in the number system, and also we finished the first one, types of numbers. Now we are going with the second one, real numbers and their decimal expansion. So we know real numbers means including the decimals, fraction, whole numbers, natural numbers, integer, all the numbers comes under the category of real numbers. So for example, if you take a fraction of p by q, so there are only two main things will happen. The first one is either we get a remainder 0 or the remainder will never become 0 and we get a repeated string of reminders. These two cases will happen on performing a division operation on this fraction. For example, if you divide a 7 by 8, if we have to put 0 with a decimal point, it will allow us to keep a 0 here. So 8 8s are 64. We have to subtract 10 minus, we have to borrow from here. It will become 10. 10 minus 4 is 6. 6 minus 6 is 0. As already decimal point is there. So 0. We can put a 0 here. Now 8 7s are, it's 56. Again we have to subtract. 10 minus 6 is 4 and 5 minus 5 is 0. Now again we can keep a 0 with this decimal point. Now 8 5s are 40. The remainder become 0. So after performing some finite number of steps, so that we got a remainder as 0. So here, so this is called a decimal expansion of a number which is terminating. So in some cases, for example, in 2 by 3, here if we divide a 2 by a 3, we will see what we get. So if we divide a 2 by a 3, so again the same is 2 is smaller than 3, so it will not go by a 3 once a table. We have to keep a 0. 3 6 are 18. Again we got a remainder 2, so we will keep a 0. Again 3 6 are, again 2, again 3 6 are, remainder 2. So the quotient will goes on repeating and the remainder also goes on repeating. This is the other case. Here the remainder will never become 0. This type of decimal expansion is called decimal expansion, which is non-terminating recurring, and this type of decimal expansion, in this case the decimal expansion is called terminating. So this is all about real numbers and their decimal expansion. So now we will go with the third point, operations on real numbers. Whether the real numbers will satisfy the laws of operations. So laws of operation, in a sense, we have studied in the previous classes, like in the 8th standard, 7th standard, commutative law, associative law, distributive law. I'll just give you a quick recap of those laws. The first one is commutative law. You might have heard this. Commutative law. What commutative law says is, changing the order of the numbers does not change the sum. So even after changing the order of the numbers, the sum will not change. Here it's a plus b and here it is b plus a. So you can give any values to these numbers, the sum will never going to change. The next one is associative law. In the associative law, so grouping of the number, the way of grouping of the numbers will never going to change the sum. Here, so if we group B and C is same as grouping A and B. So here we have group B and C, here we have grouped A and B. Even after the way of grouping is different, the sum will never going to change. This says by the associative law. So you can verify these by giving a different values to the A, B and C. The third one is distributive law. Distributive law of multiplication or addition, because here we have used only addition operation. In the distributive law we use both the addition and multiplication operation. So this distributive law says that a number multiplied by a sum of two numbers, a number multiplied by a sum of two number is same as the sum of their individual products. The sum of their individual products. Here A is multiplied with the sum of B and C is same as their individual products. That is A multiplied with B and A multiplied with C. So this says by the distributive law. This is all about operations on real numbers. So now we will go with the fourth point, radicand. What is radicand means? The number inside the nth root. The number inside the nth root is called a radicand. So this nth root means it can be a square root, it can be a cube root, it can be any root. The number which is present inside these roots is called a radicand. So now we will go with the next point, laws of radicals. So we know what is radical. Radical means the square root symbol. This is called a radical. The number inside the radical. The number inside the radical is called a radicand. It's called radicand. So have you ever tried finding a square root of a 25, a 36? It will be easy, right? The square root of 25 will be a 5 and the square root of 36 will be 6. What if I ask find the square root of 50? And what about the square root of 72? It will be little tricky, right? So where these laws of radicals will come to help us. So while finding those complicated square roots, we can use these laws of radicals. The first one is square root of AB. We can write it as square root of A into square root of B. Square root of A by B. We can write it as, we can split the radical as square root of A divided by square root of B. And square root of A plus square root of B into square root of A minus square root of B is A minus C. Because if we multiply A plus B into A minus B, we will get A square minus B square. Those square will get cancelled with these square roots. So we got A minus B. In the same case, A plus square root of B, A minus square root of B, we get A square minus in the B. The square root will get cancelled, A square minus B. And the fifth one, square root of A plus square root of B and to square root of C plus square root of D, we will get the multiples of all. Square root of AC plus square root of AD plus square root of BC and square root of BD. And the square root of A plus square root of B whole square. We know the formula of A plus B whole square, that is A square plus B square plus 2AB, that is A square plus B square. The squares will get cancelled with the square root and 2AB, 2 square root of AB and square root of A square. Here the square root and the square will get cancelled. We got A and n square root of A into n square root of B. We got n as a common and square root of A into B. So these are the laws. We will get more into it while solving the problems. So now we move on to the next point, rationalizing the denominator. When the denominator of an expression contains a term with a square root. When the denominator of an expression contains a square root, the process of converting into its equivalent expression whose rational number, whose denominator should be a rational number, that is called rationalizing the denominator. That means this is the expression where the denominator contains square root. So how we can rationalize this means we have to convert this denominator into a rational number. How we can do that? So we have to equate this into, convert it into equivalent expression. How to convert an equivalent expression? So we have to multiply and divide with the same number. If we multiply and divide with the same number, so we will get the equivalent expression of this. So what we will get here? Square root of 1 into square root 2 is square root of 2 and square root of 2 into square root of 2 is 2. If we multiply square root of 2 into square root of 2, we get square root of whole square. This square will get cancelled and 2. Here instead of this we got a rational number. This is called rationalizing the denominator. So now we move on to the last point, laws of exponents. we have some predefined, that's already proven laws of exponents. So here the first one is a to the power m into a to the power n. For example, so here the base are same and the exponents are different. For example, 2 to the power 4 into 2 to the power 2. Here the bases are same and the exponents are different. What the law says, a to the, we can write it as, we can take that base common and we have to add those exponents. So we have to take that base common and we have to add those exponents, that is 2 to the power 6. This is same as this. In the same way, the next one is a to the power m divided by a to the power n. We can write it as a to the power m minus n. So if we take this into the numerator, so it will become minus exponent. This exponent will become minus. And the third one is a to the power m into b to the power m. So if the bases are different and the exponents are same, we can multiply those base. So a into b whole to the power m. We can take this exponent as common, ab to the power m. The next one says a to the power minus m. If the exponent is negative, so if the exponent is negative, we can, how to make this as positive? We just take a reciprocal of that. So we have to, we can write it as 1 by 3 to the power 4. So a to the power minus m is equal to 1 by a to the power of plus m. So if we take a reciprocal of 3, the exponent will become positive. The next one is a divided by b whole to the power minus m. So in the same way, if the exponent is negative, we have to take a reciprocal of this. That is b divided by a, the exponent will become positive whole to the power m. The next one is a divided by b whole to the power m. So this we can split it as, if it is like 1 by 2, if it is 3 by 4 whole to the power of 5, we can split this exponent. So because this exponent belongs to both the numbers, so we can write it as e to the power 5 divided by 4 to the power 5. That is a divided by b to the power m is equal to a to the power m divided by b to the power m. And the last one, the very important one, is the number, the base can be anything. So anything to the power 0. So this base can be anything. So anything to the power 0 is always equal to 1. It can be 1 to the power 0. It can be 768 to the power 0. It can be 1 crore to the power 0. The value will be 1 with a one condition, that is these a, b, m, all these numbers should be natural numbers. It is the only condition we have in the laws of exponents, and these are the some major laws of exponents we commonly use while solving the problems. So this is all about the major key concepts we have in the number system. These concepts are very much necessary to understand and solve the exercise problems. So please do subscribe and hit the bell icon so you will not going to miss the videos. In the coming videos, I am going to start with exercise 1.1. We will solve the problems one by one, and thank you.